Good morning all. Today I am going to discuss classification of materials. Material. Materials are broadly classified into five types: metal, polymer or we say non-metals, ceramic, composite and smart materials. Metals are divided into and two types: ferrous and non-ferrous material. I discuss later in the next slide. Polymers are classified or non-metals are classified into thermoplastic, thermoset, electromers. Ceramic may be into one glasses or crystalline ceramic. Composites are metal matrix, ceramic matrix and polymer matrix composites. And finally we go to discuss the smart materials. Now we enter first one, classification of material. Before I go into the classification of material, everybody have to know some understanding of periodic tables. See, periodic table, everybody know this, there is a 118 elements. In 118 elements, first row, that is from left side, this is we called as an alkali metals, and second column we called it as an alkali rare metals, and we have a transition series of D block, that is an transition metals, and we have an post transition metal series. Then metalloids, non-metals, or we called as another non-metals: carbon, nitrogen, oxygen, phosphorus, sulfur, selenide, and we have an halogens, noble gas, lactonides and external series. So in this series, the metals are maximum in the left side of your periodic table and non-metals on the right side of your periodic table. So first one I classified as a metal. So generally what we all know about metal. Metal have a good electrical and thermal conductivity and they are malleable. This is what everybody we know. Example, what is if we say few example of metal are solid, iron, copper, aluminium, and moreover zinc, silver, lead, etc. So sometimes metals are classified as an alloys. So we broadly classify metals into two types. One is ferrous metal and non-ferrous metal. So what is ferrous metal? Ferrous metals are rich in iron. Everybody know what is iron. So ferrous metals are magnetic because of an iron nature and capable of little resistance to the corrosion. So what is the example for ferrous metal or metal? First one is a mild steel. So what is mild steel? It have some few percentage of carbon. It is strong, ductile, buildable and inexpensive. Where we use these type of mild steel, we use in a day-to-day applications. That is, we use a mild steel in building framework, railway track, automobile bodies, sometimes in a home, gates and grills, nuts and bolts. They we use the mild steel. Next one is an stainless steel. Stainless steel contains some chromium, few percentage of chromium. So why we use a chromium coat? Chromium coating is to protect you the oxidative layer, that is an prevention of corrosion. So where we use these type of stainless steel, kitchen sinks, surgical instruments, sometimes food processing equipment. And one more example is in cast iron. Cast iron is a high percentage of carbon. It is that is an excellent strength. That is, and it has an comparatively brittle nature than all. So we use the cast iron in engine blocks, machines beds, drainage pipes, manhole covers. So next classification is non-ferrous metal. Non-ferrous metal, these metal have a lightweight compared to the ferrous material and high conductivity and less corrosion and resistance, and also it is non-magnetic property. It has a magnetic but it is not comparable to the ferrous magnetic. So it has some minimal iron composition only. So example, aluminium. Aluminium is a lightweight and easy to shape. So example where we use aluminium is in an aircraft, window frames, sometimes in aluminium beverage crans, cooking vessels. Next example of non-ferrous metal is copper. Copper is a way we all know copper have a high electrical and thermal conductivity. Where we use a copper is in an electrical wiring, motor winding, and some circuited printed circuited boards or wherever. Then heat exchangers, pipes. We for usually for an hot transferring of hot water. And titanium. Titanium is a low density, high strength, and it has good biocompatibility, where we use a titanium as we use in medical implants, artificial joints, marine equipment, we use a titanium. So next material composition is a non-metal. We say non-metal, as in the slide, non-metals, we can say non-metals or polymers. Non-metals refers to the chemical element that is volatile in nature, insulate to heat and electricity, and lack of metal-like attributes. So non-metals are classified into three types. First one is then thermoplastic. So these non-metal is more or less in a polymeric nature. So according to that, I classified into three types. First one is a thermoplastic. That is an polymer which can be molded to some specific heat. That is an we get solidified upon cooling, known as a thermoplastic. So we can reshape the we reshape the material into n number of times, and it also recyclable. We call it as a recyclable polymers. Practical example, polyethylene. That day-to-day life we use in plastic carry bags, that is in polyethylene. Best example for this thermoplastic: bottles, water tanks, toys, and cable insulations. And another type of thermoplastic is a polyvinyl chloride used in water pipes, raincoats, sometimes polypropylene. We also used that as a thermoplastic. Next classification is thermosets. So these are the polymers, that is, it is capable to resist an high temperature. It can withstand within high temperature. So once thermostat we formed, it can't be reshaped or remolded. So they are we called as an it is not able to recycle. So best example is backlight, that is used in electrical switches, plug boards, some type of saucepan handles, or example for this that is an example. And a epoxy resin, polyester resin, these also come under the example. Next classification is elastomers. So electromers is mostly like an elasticity, that is an it can be deformed under stress and regain its original shape when we remove the stress. So it is an classification of simple polymers. So where what are the examples? Natural rubber, we used in tires or rubber band or footwears, where we use silicone rubber, that is an for silicone rubber cooker gasket, seals, some medical tubes, we use for withstand of high temperature resolution. And nitrile rubber used in for some fuel hose, that is petrol hose, that we use these type of electromers. Next one is in ceramic. Ceramic, we named as generally ceramics or belong to an inorganic and non-metallic compounds. It have an high strength and hardness property. Example we say is here we say the plates, tiles, some of Teflon, that is also that is an toiletry, that is also the example for ceramic. Ceramic is broadly classified into two types. One is crystalline ceramic, glassy ceramic. First we see a crystalline. Crystalline is a more brittle and harder than metals, but it has a tensile strength is very less comparable to metals. So where we example for crystalline ceramic is alumina, that is Al2O3. We use for some grinding wheels or artificial hip joint, we use alumina. Silicon carbide, we know silicon carbide is strongest, we used as a furnace component or some of mechanical seals. Zirconia, that is ZrO2, that is also an example for crystalline ceramic. Silicon nitrate, that is an example. Glass are also an inorganic and non-metallic, but it is in special properties. This type of ceramics look transparency because glassy structure, so it is more or less transparency. So example, soda lime glasses, borosilicate glasses, that is used in our laboratory glassware, optical glasses, these are the example for glassy ceramic. Next one is in composites. Composite is a material, it is form of two or more material to attain required property like high strength with light in weight. So example, day-to-day easy example is on plywood. Plywood is a composite material, that is it is a composition of different type of wood material, and fiberglass is also an example for composites. Composites is classified into metal matrix, ceramic matrix and polymer matrix. So next one, smart materials. So here as in shown in a figure, unlike conventional material, smart material possess an ability to sense, process and respond to the environmental change without continuation of human intervention. That is the speciality of smart material. They are the combination of sensation, acquisition within the material system itself. So that is a highlight of smart material. Smart material is generally exhibit in three functions: sensing as an external stimuli. See in the figure, we have a smart materials. If external stimuli we induce that humidity, magnetic field, or we give temperature, light, or pH, it process and accordingly it receives the information and responding by changing one of the physical property, like it can swell or it can change the shapes, or it can deform in nature. So accordingly this is the main smart material where we use these type of smart material we use in aerospace, biomedical engineering, robotics, some of automatic system and wearable electronics. We use smart materials. So in detail, smart materials, I classified and I put a table, nice table with a few example types. First one is an shape memory alloys. Shape memory alloys can return to their original position when we give an temperature. That is when we give the heat, even after being deformation. Some of common examples, I just say examples. Shape memory, the external stimuli is temperature, its shapes recover. So day-to-day life example is nitro, that is a nickel titanium we used in a medical stent, where we use that for biomedical application, orthodontic wires or septical frames we use that. Second one is a piezoelectric material. Everybody know the piezoelectric material is an, it produces electrical voltage when we give an mechanical force or pressure is applied. So they can also deform. If we remove the electrical voltage, it again reform. So that is the main usage of piezoelectric material. Example is common quartz, lead zinchronate, PSD. These are the materials we use. Where we use this, it is used for in an pressure sensors, ultrasound scanners and vibration sensor. We use the piezoelectric type materials. Magnetocaustic is change dimension when we give an or when under an magnetic field. So practical example is an tenfold and nickel or the common example where we use this these type of material practically in a position sensor, vibration control device, some type of precision actuators. We use the magnetocaustic materials. Then one is an electrochromic material. Electrochromic means it changes the color or transparency when we apply an electric voltage. So now example is tungsten oxide. So where we use is anti-glare rear view mirrors, aircraft windows, we use these type of electrochromic. Then electrohectic fluid, that means that it is fluid free flowing of liquid into thicker or semi-solid material when we apply an electric field. So example is an where we using a braking system, shock absorbers or some type of robotic devices, we use this type of material. Shape memory polymers, that is we all know polymers means if we apply and same first as the shape memory alloys, shape memory polymers, here we use an polymer material. So in medical application like soft robotic components, some type of polymers that we have, and flexible devices we use shape memory polymers. Smart gels, it can swell or shrink. See few of we have and some heating pad, that is, and it can absorb the heat, that is its shapes response to an temperature, pH, moisture or light. It is depend on that. It is an common example is hydrogels, some type of contact lens, biosensors we use for smart cells. So these are some smart materials I can put where we, that is the automobile industry, biomedical, aerospace, robotic, and I want to discuss the few advantage, that is the merits and demerits of smart materials. It is an first one is a merits. Its self sensing capability is very good. It's lightweight, high energy device, fast response, and it is multifunctional. So demerit may be in a high cost, complex fabrication, it can fatigue after repeated cycle. We can only operate at the limited temperature, and smart materials, some of it is difficult to integration. So that, thank you.